What we learned so far, we learned that if the distribution of a random variable like x is approximately normal, then this variable t, which is x bar minus mu, divided by s over square root of n, follows a t distribution or a student t distribution. What is s? S is the sample standard deviation. So when standard deviation for population is missing, you're going to follow a t distribution. Critical values of t are denoted by t sub c. Here are several properties of the t distribution. The mean, median, and mode of the t distribution are equal to 0. The t distribution is bell-shaped and symmetric about the mean. The total area under the t distribution curve is equal to 1 or 100%. The tails in the t distribution are thicker than those in the standard normal distribution. The standard deviation of the t distribution changes as the sample size changes, but it is always greater than 1. The t distribution is a family of curves. Each one is determined by a parameter that we call the degrees of freedom. The degrees of freedom, sometimes abbreviated as df, are the number of free choices left after a sample statistic such as x bar is calculated. When you use a t distribution to estimate a population mean, the degrees of freedom are equal to 1 less than the sample size. So degrees of freedom can be calculated as n minus 1. And again, n is the sample size. Now, the visualization is like this. If the degrees of freedom is 2, the graph is above t-axis. There is a distance between the graph and t-axis. As you increase the sample size, the degrees of freedom increase. And the graph is getting closer and closer to a standard normal curve. Officially, after 30 degrees of freedom, the t distribution is very close to standard normal distribution. Which of the following statements are accurate? Students' t distribution is necessary when the population standard deviation is not given. T and Z are both test statistics that measure how many standard errors a sample mean is from the population mean. T is a statistic, a value that measures something using sample data. T is parameter, a value that measures something using population data. And finally, students' t distribution is another name for the normal distribution. Remember that. Students' t distribution is important when the population standard deviation is missing. When it's missing, you only have sample standard deviation, not population. So when population standard deviation is missing, you're going to use t distribution. T and Z are both test statistics that measure how many standard errors a sample mean is from the population mean. So the second statement is also true. Please note that T and Z are both statistics. These are related to the data. T is a statistic, a value that measures something using sample data. It is not a parameter. We are not using population data. We're using sample data to calculate T. And finally, student T distribution is not the same as normal distribution. Next question for you. Which one is true? Students' t distribution, unlike the normal distribution, changes shape based on the sample size. Students' t distribution looks more and more like the normal distribution as sample size increases. Students' t distribution gets wider in the tails as the sample size increases. And empirical rule 68, 95, 99.7 applies to the t-distribution as well. And finally, the last statement says degrees of freedom is another name for sample size. Remember that students' t-distribution, unlike the normal distribution, changes shape based on the sample size. Normal distribution has a fixed graph, but students' t-distribution is a family of graphs. Students' t-distribution looks more and more like a normal distribution as sample size increases. Of course, students' t-distribution gets wider as the sample size increases. Well, remember that it's getting narrower. It's getting more close to standard normal distribution. And finally, the empirical rule doesn't apply to the t-distribution. And of course, the degrees of freedom is not the same as the sample size. We use sample size to calculate the degrees of freedom, but it's not the same as the sample size. It's the number of free choices left, not the sample size. Take a look at this sample. Question says, calculate the standard deviation for sample A, round to 2 decimal places. So let's take a look at our calculator, everybody. Let me share the screen with you and show you how to do the computation. So here we go. I'm going to go to Stat and Edit. I'm entering everything in L4. So all of these 1, 2, 3, 4, 5 data are entered in L4. I'm going to go to Stat and use arrow key to go to Calc. My cursor needs to be on one variable, statistics. Hit Enter. Make sure it is L4. Frequency list must be empty, and then do the calculation. It says, hey, the average is 501.8, and the standard deviation is 21.545 or 21.55. So the standard deviation rounded to 2 decimal places is going to be 21.55 kilogram. Question says now calculate the t-statistic for the sample. Assume that the population mean weight mu is 475 kilogram. Remember the definition of the variable t. Variable t-statistic is x bar minus the mean divided by s over square root of n. X bar is the mean of the sample, mu is the mean of the population. S is what you calculated in previous slide, divided by square root of n, and n is 5. 1, 2, 3, 4, and 5. So let's begin. T, capital T, small t, both of them showing the exact same thing, is x bar, which is 501.8 minus 475, which is given in the question to us, divided by 21.55, which is your sample standard deviation, divided by square root of 5, which is about 2.78 kilogram. So let me show the calculator to make sure you know where we got this information. So again, x bar is the sample mean that we calculated here, 501.8. 475 is given in the question to us. Take a look, 475. S, which is your sample standard deviation, is 21.54, which we rounded that up into 21.55. Why is that? Because you had a 5 here. So to get rid of this 5, you add 1 unit here, divided by square root of 5, which is about 2.78. So what's the next step? Let's take a look at sample B. This is sample B, and question says, find the mean and standard deviation of this sample now. So let me share the screen with you and show you how to use your calculator. You need to go to Stat, in Edit, go to L5, enter these numbers in L5. So you have 493, then you have 482, then you have 431, then you have 450 and 452. So again, note that I entered everything in L5, everybody. I'm going to go to Stat, and then I'm going to go to Calc using the arrow key. It must be on one variable, statistic, and hit Enter. You need to change L4 to L5. So let me delete this. Second, 5 gives you L5. Frequency list must be empty, and your cursor needs to be on Calculate, hit Enter. Okay, as you can see, the mean is 461.6 with standard deviation 25.32. So let's take a look at our answer here. 461.6 is the mean, and the standard deviation is 25.32. Let's go back to our calculator and double check everything. Mean is 461.6 with standard deviation, which is 25.32 kilogram. So everything is the same as what you calculated using your calculator. Now, what's the next question? The next question says, hey, calculate T statistic for sample B now. But remember the formula, T is equal to x bar minus mu divided by S over square root of n. T is equal to x bar, which is the average that we calculated in the previous slide. 475 is given to us in the question because it says, hey, the population mean is this number here, divided by 25.32, which is the sample standard deviation that we calculated over square root of 5. And it is negative 1.18. Again, if you look at your calculator, you see you calculated all of these before. So we entered everything that we had, 461.6, which is the average, minus 475, which is given in the question to us, divided by S, which is 25.32, which is this number here, sample standard deviation, divided by square root of 5 because you have 5 data in your collection. Perfect. So which T statistic indicates that the sample mean is below the population mean? The population mean is 475. If you compare the T values, the T value for sample A is 2.78 and T value for sample B is negative 1.18. What's the meaning of that? It means that sample B is the answer. The negative test statistic indicates that the sample mean is below the population mean. So that's the meaning of that. If you get a negative T value, it means that the sample mean for the T value that is negative is below the population mean. And remember that this T value is for sample B. So the answer is sample B. which t-statistic indicates a sample mean that is closest to the population mean. Okay? Sample B again. If you just ignore the sign plus minus of the t-statistic, the smaller number indicates fewer standard error. It means that it is closer to the mean. So the answer is sample mean, sample B. Why is that? Because again, it has a smaller deviation if you're going to talk about deviation. It is very closer to the population mean because 1.18 is less than 2.78. 1.18 is for the second sample, sample B. And finally, use the t-distribution critical value table to find a critical value t sub c that corresponds to 90% confidence level and a sample size of 11. So take a look. 90% on the very first row. Sample size is 11. So the degrees of freedom is 11 minus 1 or 10. Now we need to find the intersection between these two row and column. So as you can see, the critical value is 1.812. If you want to visualize this, it says, hey, 90% is my confidence level. Critical values divide the probable sample statistic from improbable or unusual ones. TC is 1.81. So again, the confidence level is 90%, degrees of freedom is 10. The image displays the t-distribution curve with 10 degrees of freedom. 90% of the values in the t-distribution with 10 degrees of freedom are between the opposite of the critical values, negative 1.81 and positive 1.81. In other words, 90% of the values are within 1.81 estimated standard error of the mean. So if I ask you to calculate the confidence interval, you can use your calculator. To use your calculator, we're going to let me share the screen and show you where to go. To use your calculator, you need to go to Stat and find Tests. And then you need to find T interval, everybody. So your cursor needs to be on T interval. T interval. Hit enter. You have the statistic of the data. You don't have the actual values. So if you enter X bar and then standard deviation of the sample and enter N, you can easily find the confidence interval for the data. So here you have the confidence level is 90%, 0.90. If you do the calculation, it says, hey, the lower bound is 437 and upper bound is 485, 486 if you want to just round these. So using your calculator makes it much more easier to do the computation, but we need to have the correct values for our data. You can go back to Stat and go to Tests and go to the T interval. Here you can use your data. Data we use L4 and L5. So for example, if I click on second 4 and C level is 90%, it gives me the confidence interval for sample A. If I want to find the confidence interval for sample B, I go to Stat, I go to Tests, and I go to T interval. And now if I want to use my data, I need to change L4 to L5 because my sample B data is in L5. So second 5, frequency is 1, confidence level is 90% and do the calculation. And this is going to be your confidence interval.